The degrees of freedom is the number of independent values or quantities which can vary. Remember this word, which can vary in a statistical calculation without violating a given constraint. Let me explain it with an analogy. Suppose you are having a pizza party at your home and you invited Alice, Ben, Kathy, and Dan. And all of them have to eat exactly 20 slices of pizza. Now you start recording. Alice ate 6 slices, Kathy ate 4 slices, Ben ate 7 slices. Now, how many slices Dan must eat? So, what's the catch here? Dan can choose freely. The total must be exactly 20 slices. That was the given constraint. So, Dan must eat exactly 3 slices. That's what we call degrees of freedom. There are 4 people, but only 3 can choose freely. Dan must eat 3 slices. So the degrees of freedom here, 4 minus 1 is equal to 3. Another way of looking at degrees of freedom is as the penalty of small sample size. Because degrees of freedom reduce the amount of free information we have when we are estimating something from a sample. So the smaller samples, the fewer degrees of freedom and the greater the uncertainty. For example, in case of small samples, say n is equal to 2, degrees of freedom would be exactly half of the sample size. But if the sample size is big, like 5,209, 1 is not going to make any difference. And we'll see the degrees of freedom in action when we will talk about p-values next.